Hello and welcome to Chapter 5 Network Security and Monitoring. Today's chapter, even though I think it's short, but I think there's a lot of good information in here that can help you manage and troubleshoot and mitigate against a lot of the attacks on a local area network because that's where most of the problems really happen. So we're going to discuss land security, how to secure your land from different types of attacks. And we'll look at we'll look at the SNMP protocol and how it can help us monitor the network for not only attacks, but also for traffic purposes. If you are thinking about growing your network. And then we'll take a look at the span ports on a switch, the Cisco Switchport Analyzer that's going to help us analyze all the packets that are going in and out of a switch, and we can actually take these frames that are coming into and out of the switch and analyze them and display them um, in a GUI interface that can help us track abnormal traffic or and display those traffic in a GUI interface. All right, so let's get started. When it comes to LAN security, the different common attacks that happens on a layer 2 are CDP reconnaissance attacks, telnet attacks, the MAC address table flooding, VLAN attacks, and DHCP attacks. CDP reconnaissance attack, the Cisco Discovery Protocol is enabled by default on the Cisco devices, the switches and the routers. So you can type and send in information to your neighbors, and your neighbor will send you information about um, the IP address and the interface and what type of router or switch that's directly connected to you. And of course, that could be used um, for attackers to use information. So one of the first thing an attacker would do is do reconnaissance. Find out who am I connected to, and what kind of information they can give me, so I can use that information to attack the device. So it's probably a good idea to disable CDP. Okay, we'll talk about mitigation in a second. Telnet attacks. Telnet attacks is when there's two different really types of telnet attacks. There's the one that you can use guessing your password using brute force. You keep guessing your password. That could create a lot of traffic into your network, even though the password may be very difficult to guess as long as your password is long enough. And the other type of telnet attack is somebody's trying to make a connection. Um, and that could be a problem too, because the legitimate user that wants to telnet into your network may not be able to because somebody keeps trying to telnet into your network. So we'll have to fix that too as well. MAC address tabling flooding attack. The MAC address, as you probably already know, keeps track of the MAC addresses and whose their IP addresses are. I'm sorry, the MAC addresses in the switch and which ports they are connected to. So what I could do is I can flood the MAC address table with bogus IP addresses, and then nobody will be able to send in their if the MAC address table is full of bogus MAC addresses, then you really turn the switch into a hub, because what a switch does when it receives a frame and it does not have the destination MAC address in the MAC address table, what the switch does, if it floods, which means it sends all the frame to all the other ports, and that's exactly what a hub does. So that's good. That could be a problem with the MAC address table. So we'll fix that as well. VLAN attacks. If you have the unused ports on a switch, the unused ports on a switch, by default, they are set in dynamic. The dynamic trunking protocol is enabled by default on all ports on the switch. And what that means, if somebody connects to it and that someone says I'm going to be a trunk and sends that information to that dynamic port switch, the switch will immediately become a trunk. Then that someone, the attacker, will be also set up as a trunk. And as you guys already know, if you are a trunk on the receiving end, all the VLANs will information will be sent to you, and you'll also be able to access all the other VLANs as well. So we want to avoid this. So we'll talk about how to mitigate. One thing is you got to make sure you shut down this dynamic trunking protocol by making the port, for example, switch mode access, make it only a data port. DHCP attacks. There's two different types of DHCP attacks. One attack is somebody pretending to have another DHCP server. So so you go there instead of going to the legitimate one. And when you go to that spoofed or rogue DHCP server, he'll give you IP addresses that probably send you somewhere else, unintended place to go to. And the other type of DHCP attacks is going in there and assigning IP or starve the DHCP server. Use up all the pool addresses. So if somebody's trying to get an IP address, won't be able to get an IP address. All right. So how do we mitigate against all of this information? I took some notes. I wanted to wait. So let's take a look at some of the notes that I have, and I want you to write these down. So we'll start this is what you need to do for chapter 5. So you start writing from LAN security. These are the different types of attacks that we talked about. The CDP reconnaissance, the telnet attacks, the MAC address attacks. I want you to write all the different types of attacks and what they are and how. So you take these notes. You don't have to remember what I said. Just pause this whenever you need to and just write down the different types of attacks and the definitions of each one of them. All right, now here are the strategies on how to secure or mitigate against these attacks. So I want you to write everything that I'm showing you right here till we get back to the slides. You always want to use variant protocols such as secured shell instead of telnet, secured copy protocol instead of FTP maybe, or secure FTP, simple management protocol version 3, use SSL, HTTPS when you are accessing the internet. Always use strong password. I mean, we always said that many times, or change them periodically, maybe every 3 months or so. A strong password has to be at least 8, probably a minimum of 10 characters with the complex rule. Um, Capital letters, lowercase letters, and maybe some numbers in there. Enable the CDP only on selected ports. That means you have to disable everything. All the CDP has to be disabled on all the ports. Secure your telnet using an access port, using an access list. We did that before, and probably a good idea to not even to use telnet, use SSH instead. Use a dedicated management VLAN. You create a VLAN 50, and only to VLAN 50 you assign the IP address. And use an ACL to filter unwanted access. So only people that you want to access will use the ACL. ACL, only people that may, for example, that going to telnet will use the ACL, and not everyone. All right, so maybe we'll practice some of this in class for our class activity. To mitigate MAC address flooding, you enable port security. All right, so remember Switchport port security, and we do the maximum one, the sticky, and all that wonderful stuff. Do all of that to all the ports on the switch that are attached to desktops. Against VLAN attacks, you want to disable the DTP. Okay, so you switchboard mode access. That's easy to do. So just make sure, go to every interface and make it switchboard mode access. It's no longer dynamic. And by the way, to be able to set security on a port, you do have to switch port mode access. And then if you need a trunk, you just go to those access ports and then do switch port mode trunk. Okay, so you don't just, and you got to do it to both sides. So one of the first thing you do when you get a switch is make all the ports access, or you can even type shutdown. All right, disable the DTP by typing, you go to the interface and type switchboard non-negotiate. So you have to type in switchboard mode access on one side, on both sides. So you don't automatically become a trunk of somebody attached to you when you type in this command. All right, set the VLAN to something other than VLAN 1. We did that, I think, a while back. So when you type in switchport mode trunk, then you say switchport trunk native VLAN 99 maybe. And make sure that VLAN 99 is not populated with users, right? Disable all unused ports and assign them to an unused VLAN. If you leave VLAN 1 unused, that's fine. But it's probably to create another VLAN like VLAN 99 and or VLAN 50 and make sure nobody is using it. Disabling it, meaning that you're shutting it down. And of course, implement port security like we said earlier. You do switchboard mode access and then switchboard port security, and then you can set your maximum number of hosts that can be attached to that port, and then you want them to be sticky, and the violation should be always shut down. All right, how do you mitigate against DHCP these DHCP attacks? Now, you want to enable maybe DHCP snooping on a switch, and the switch will know now if a port comes in and he is asking for an IP address from a DHCP going upstream. You say, okay, you're a trusted port. That means you go right ahead. If somebody comes in and says, I want to, you can create ports that are trusted and untrusted. What that means is a trusted port is if you have a DHCP server that is attached to the port and he is allowed to send out IP addresses. If a port that is untrusted and they should not be giving out IP addresses. So every message that comes in for a DHCP is going to be compared inside the switch to see if you're trusted or not. If you are trusted, you're allowed through. If you are untrusted, then you won't be able to get through. Even to get an IP address, you won't be able to. So you set the ports of who is allowed to get IP addresses from the DHCP server and who is not allowed, which ports. And you can also set the ports of who is allowed to give out IP addresses. All right. So those are the trusted on untrusted ports using the DHCP snooping. When it comes to the AAA, that means we will learn a little bit more about that later on, the authentication, authorization, and accounting. You want to be able to you want to authenticate users using a username and a password. You want to be able to set the authorization, what resources that they are authorized to use. That's after they've been authenticated, and then keep an account of them, of what they have done after they've been authorized. Did they really use what they were authorized to use? And you get a list of all the different resources that they have accessed. All right, so this is a really easy setup. You can set up either a radius service or TACX service to do all of that for you. But we'll discuss more of the AAA in our Security 453 class. Secure device access using the 802.1x. You can set up the ports so that the ports will not open up, or the port will be open. You're assuming that you have a radius server or TACX server, an authentication server. is connected to the switch and it's configured. So all the traffic that comes into the switch will open up the ports to allow the data to get to this authentication server. Only the authentication server will tell the switch to either to open up or disable the port or shut down the port if the user is not authenticated. Not shut it down, really block the user from accessing the switch. So the ports are only going to they're only allowed when you first turn the switch on. Only 802.1x messages are being sent and received through the ports to allow them to be authenticated to the server. Then the server will instruct the switch to either open up or block the port. Okay, so that's a very important, by the way. This is what the WPA2 security uses to wirelessly, believe it or not, um, for access into your wireless network. All right, so please write all of that down on how to secure a LAN and to mitigate against all of these different types of attacks. So maybe we'll practice some of this um, next in our class activity. All right, moving on. So we talked about all of this. Okay. Um, let's continue. Now we're talking about the Simple Network Management Protocol. The SNMP is a protocol that allows the administrator to manage and monitor devices on an IP network. So if you are a manager, you could do it on your either router or a PC that has software. What you do is, these are agents. So the agents will have the software, will have a database that they keep track, the message, I think, database. So what I do is they have them already in there. So I can get information from the agent. They send a trap to me and information to I get all the information that I want, and I can, maybe about the interface on the router to see if it's up and down, how many packets is going through in it, and any other information. So I can get all of that information in there. The set command is to change the MIP, the database that's in the agent. An agent may send me a trap if there's a problem, for example. Um, Maybe the interface went down on the router, and then the router will send me a trap telling me that the network is down. So when I get that information, all I have to do, I may display that as a really red icon next to the interface on the router, or maybe it'll send me a message or a window might pop up telling me that phase 00 has went down. So you'll have some GUI interface when you get all these different traps, or that information from the agents will be displayed on the monitor and tells you the different types of traffic and maybe alerts that the network is doing. So this way you can actually find out where the bottlenecking of the network, and you can easily mitigate against the traffic and maybe different attacks too. And you can scale your network and ease the traffic by adding more, changing VLANs or whatever. All right. So the SNMP can help you really monitor the network, not only for traffic, but also for attacks as well. All right. There are three different types of SNMP. There are versions 1, 2, and 3. You want to use the bottom one, version 3, because it allows you to authenticate either using the MD5 or the secured hashing algorithm. Very strong authentication. The passwords and the information, that all the traps that are being sent back and forth are encrypted. So definitely that's what you want to use. You don't want anybody with a sniffer or protocol analyzer to be able to decipher all the data that's being in transit between you and the SNMP, you meaning the manager, between you and the SNMP agent, right? All right, so first of all, we forgot to, this is what I want you to write down for the SNMP, this information right here. What is an SNMP? The SNMP manager, an SNMP agent. See if you can describe what each one of those are. The trap is the information that's being sent from the agent that the manager can use for information. The get is when I request something to go in and read from the agent, and set is to make changes into the MIP. That's the database that's being stored on the agents. All right, so there are, how do you configure the SNMP? Well, the first one is really needed. You need a password, that's a community strings. So you write SNMP server community, that's the like writing the word password. So SNMP server community, and then you type in your password is Patanong, and then read only. So that means I am going to read only. For read only, if you type RW, that means you can do you can write as well into the MIP. So all I want is being able to read that information. All right, so I write that in there, and I say, and I'm going to use an ACL to allow me. So I'll write down, by the way, the rest, all of this are going to be optionals, really. So I set R1 to send me information. So I'm going to say IP access list standard SNMP underscore ACL, and I'm going to permit 192.168.1.3. So I'm going to, if somebody comes in and he wants to read only information from the SNMP server, and it's going to say, okay, I got to check the SNMP under underscore ACL, and is he the 1.3? Yes. Okay, then he's allowed to have access to my MIB database and get all the information he wants. Right? That's pretty much it. But if you enable, for example, here's a good option that you should use too. SNMP server enable trap. You allowing R1 to always send traps to this guy 192.168.1.3. So if there's any information, useful information, such as, like we said earlier, the interface has went down, send them an IP, send them a trap, right? You can SNMP host version 2 and 2C probably. I don't bother any of it. The server contact Wayne word. This is just to log all the information. This is to set up the location. So it's probably the first line, and the last line is the most useful. Okay. All right. So securing SNMP version 3. When you use VD3 version 3 of SNMP, the best thing to do is to do these 4 steps to secure it. So you create an access list with a name and who is allowed, right? And then you create an SNMP view, and then configure the group version 3 with read only the name and the access. This access list lets you create it. And then the username. Create a username with a group name, version 3, and so on. And then you type in probably triple des or AES for the encryption method. All right. So once that's set, you're all real good to go. All right. Now, when it comes to the switch port analyzer, the span ports on a switch. Typically on a switch, when information is being sent on a switch for PC1 and the destination is PC2, the switch is only going to send the information to PC2. So what we want to do is I want PC1, when he sends the information to the switch, I want also a copy of it, right? So I want to mirror this port so that the information not only sent to PC2, but it's also sent to me. And when I get that information, I can see if it's an attack, or I can analyze every and all the information that is being sent. But you got to be careful. You don't want to span all the ports to be spammed, because anybody can come in and use that for attacks. So you want to make sure you only enable it on a port that's where you're going to have either a sniffer to, a protocol analyzer that analyzes all the traffic that's going in the switch, or you can have an IPS or an IDS, an intrusion detection system that's going to detect if there's an attack. All right, so please write that down what port mirroring is. And it's basically is getting a copy of every single frame that's being sent on the switch for analysis purposes. All right. So you are going to decide which ports are going to be the ingress, coming in ports, and this is the destination port. So all the ports are the ingress ports are the ports that are all the frames that are coming in, and this is going to be the span port right here, the destination port. Okay. And there is something called remote span, which means if the RS is on if the sniffer is or the IDS is somewhere else. So you can set these up as span ports. They don't have to be on the same physical switch. So could be a span port. So is this. This is a span port, so that information has to be sent to the trunk to get to the other switch where the sniffer is. That's called remote span, the topology for it. So it doesn't have to be everything is dedicated to one switch, because your sniffer or your IDS could be attached on a separate switch. All right. And here are the commands to set it up. So we'll be able to do something like this in class 2. You can say fast Ethernet 01 is going to be the source where the information is coming in, and fast Ethernet 02 is going to be the destination. This is where you're at. That's it. So you use a monitor session 1, source, destination, and you're all good to go. The span is set. You just got to make sure that you have your IDS set up to the destination port, and all the information, any frame that it's being sent on to 01 will also be sent on 02. All right, so write these 2 commands down. This is how to configure a switch for span. And that's pretty much it. All right, you can use the span as a troubleshooting tool. It allows the administrator to troubleshoot a network, of course, by doing all the analysis. All right, using either a sniffer or an IDS to to really look for patterns in an attack, and that will automatically trigger to tell the firewall to block the attack or send an alert or whatever. Or the protocol analyzer, even Wireshark, can send alerts. For example, any protocol analyzer that will send an alert to the administrator to tell them that there's a problem might be on a network. All right, and that's it. So write down what I asked you to do, and in class we'll be able to practice. We'll come up with some sort of an exercise that can apply all the span, maybe some of the attacks and how to mitigate against them. And I'll see you then. All right. Until then, keep up the good work, guys.